so the strain gauge is a critical tool for structural health monitoring, of course. So what I'm going to show is a new low-power wireless strain gauge data acquisition system. So we're coupling the strain gauge measurements with low-power wireless sensor networking, and most notably, how to very easily download custom programs to run on the node over the air, so that you don't have to be a software engineer, an embedded engineer, to program distributed nodes. You can use a graphical programming language like LabVIEW. So real quick on the actual hardware I'll be focusing on, it's a strain gauge data acquisition module. It has 4 channels with full featured, high precision, high resolution strain gauge measurements and 20-bit resolution. Acquisition speeds up to 1 kilohertz into local memory. Works on 802.15.4 wireless sensor network technology and integrates in with the IWSHM platform. So the setup I have here today is I've got a small network with 2 nodes, 1 thermocouple node and a strain gauge node. So in the strain gauge itself, I've got just a single strain gauge connected into one of the channels of our wireless strain gauge node. It's a standard 350 ohm quarter bridge strain gauge, and we've configured the node to scan the input at 100 samples per second, and it's streaming that data, all that data, 100 samples per second, back to the PC through the gateway, and our thermocouple node here is acting as a router, so we have a miniature little mesh network right here. So I'm going to switch over, and on my PC I have LabVIEW to show the actual data coming back. So just real quick, so you know this is live. We can see live data, getting real-time updates of the dynamic strain back up on the node. So what I want to show you now, kind of the crux, I'm going to go ahead and start downloading my program to the node, because it takes about a minute or so. Minutes are precious here. So since I'm streaming all that data back to the node, which may be useful for some applications, it is a relatively high usage of power and a drain on the battery. So it would be nice if we could put a custom program down on the node and only send data when it makes sense. Also, you can think if we have multiple strain gauges, all streaming data at 100 hertz, we quickly overload a network like 802.15.4. So with these nodes, we're able to take standard graphical LabVIEW programs and download them to run on the 16-bit low-power microprocessor that's in these nodes. So that's what I started. And you can do, basically, again, it's standard LabVIEW, so you can write programs that look at the data, only transmit when the data makes sense, because that's where you're going to burn most of your power, is in the radio transmission. So I'm going to jump back to LabVIEW. Sorry for the jumping back and forth. And just show you real quick the VI that's already kind of in the process of being downloaded. I should point out, too, that the code is being downloaded to the node over the air, so there's no physical connection. So the new program is downloading to the node over the air. Okay, so if I look, for those of you who are familiar with LabVIEW, this is for you. For the rest of you, just understand that this is the program, or the guts of the main part of the program that got downloaded to the node. Again, if you know LabVIEW, this is a very simple, just to show you a simple example, where we're grabbing 100 points for once a second, look at the data, check if the max value is over some threshold, which I set at 100 microstrain in this case. Only if that data is over that, I'll send back the data. Otherwise, I only send back that one data point, that one peak value. So I'm much more efficient in terms of my battery usage. Okay, I'm going to jump to see once the program is downloaded. Right now, the node is rebooting. I could download programs to both nodes, or either node they work in either a standard process or not. Okay, the node is still rebooting. Yeah, so now this is again, now we're only sending back trigger data and sending back the peak strain. Okay, it's now searching one of the features, 802.15.4 radio. It's going to search and connect to the system. Sorry, there we go. It should be good now. I'll switch back to LabVIEW, the same VI, and now it's not real obvious, but now when I create the strain signal, you'll notice it will capture that, and since it's not updating, that means data is not being sent back to the PC additionally. So we captured that waveform. Actually, we captured a couple And right now we're only transmitting back the peak value, and so we're much more power aware, much more power efficient. And so that's my demo of downloading graphical programs to make it very easy to embed programs on the wireless node. And there's where you get more information. So.
Thank you very much.
I will call our second presenter, which is Mistra's group, to start setting up the presentation. And we have about 3 minutes to ask the questions to National Instruments if there is any question.